All right. Shh. Go ahead and be quiet and listen. What? I checked. No, it's all the way. It's not that part. It's like the microphone wasn't turned on. Anyways, it's recording, so be quiet. All right, so this is the last topic on Unit 7. This is talking about logistic growth. So it's differential equations with logistic growth. There's a lot to these, and I think the good starting point would be like an example of what's happening. So there's several like real world like scenarios that make sense. The first one might be like a population of a certain animal in a habitat. So like if like you're a park ranger or somebody who like stocks ponds of fish, you put fish in the pond and they start to reproduce and the population increases, right? And at some point, the population is still increasing, but not as fast. And it starts to level off and reach its limiting capacity. So write that. That dotted, that line right there, we're going to call that L. That is the limiting capacity, the limiting value, the carrying capacity. They kind of use that interchangeably. But there's only so many fish that can live in that pond. They don't have room to swim. They don't have enough food to eat. There's a limit to it. But notice over time, the population is increasing the whole time, right? Okay, but right here, the population is growing faster than it did right here. It's still growing, but not as fast. What idea was that we've talked about in the past? It's increasing quickly and then increasing slower. Acceleration? Yeah, acceleration, right? It's a second derivative. So the first derivative on all of these is positive. Y'all agree? It's always increasing. But it's in the rate is increasing here, then the rate decreases. So we say the growth rate is increasing up to this point right here. And then the growth rate decreases up here. So still increasing, the population is increasing, but the rate that it's increasing slows down. So what would this point right here be called? No. The point of inflection, where concavity changes. It's concave up for this first half, then it's concave down for the second half. The second derivative change of signs, that's the point of inflection. That's the point T, L over 2. The special thing is this Y value will always be right in the middle of, or exactly half of the limiting value or the carrying capacity. So if this was 1 million, then the Y value here would be 500,000. Okay, another example. So we said like fish in a pond. Might be, I asked first period if they knew what a VCR was. VCR, and I felt really old. VHS? Yeah, the VHS goes in the VCR. The VCR. It's the VHS player.
What's a VHS?
It's an old type of tape. Okay, so let's come into the 21st century. So DVD players. Those were those things before Blu-ray players. So when DVD players first came out, no one could afford them. And no one had DVDs. There's no point to buying a DVD player because you had all VHSs. Okay, but VCRs start to break. And people like, I'm not going to buy another VCR, buy a DVD. DVDs are becoming more popular. DVD players, everyone starts getting them. But then everyone starts to have them and less people buy them. And then you really just buy them because your old one breaks until the new thing comes out. So like products like that have like a cyclical pattern. So I guess DVD players or like PlayStation 4s. no one had a PlayStation 4 at first because they're hard to buy. They wouldn't. And then people start getting PlayStation 4s. Then you get all your PC or PlayStation 4 games. And then you're like, okay, well, that broke. And PlayStation 5's coming out. So who buys a PS4 anymore? What?
Like, imagine a person buying a
Right, this is before that happened. This was the PS4 version. Why do you like this? Okay, another one would be like viruses. Coronavirus. Although I can't say coronavirus on YouTube. I'll get demonetized. Doesn't count, no money.
We gotta flatten the curve, guys.
Okay, so at first, no one has coronavirus, then everyone and their mom has coronavirus, then you get immunity, and then no one gets coronavirus. What we kind of do, and it levels off. Okay, one thing about this is the solution curve. Okay, this is in respect to T and population. Okay, that's not a differential equation. That's the solution. All right, I need to get this part down. Okay, on the homework answers, I wrote that you had to memorize something. I don't think you need to memorize this stuff because on all the examples I've seen, it tells you. Okay, so the derivative of a logistic function might look like this. K times y, 1 minus y over k, y over L. Could look like that. That's like the most common one. L is the limiting value or the carrying capacity, like the max. The other one could be K over Ly, then L minus y. Or K times y, L minus y. They all kind of like, I've seen them all. Okay, the big differences, or the main thing we need is to be able to look at the equation that they tell us and find out what L is. It's going to tell us almost everything. So in this case, it's the 1 minus, in the fraction, the L is on the bottom of the fraction. If it's a number minus y, the first number is the L number. These could be different. Sometimes they have the L out in front, and then sometimes it's a different K number. Sometimes that's just the K number with L factored in. Okay, let's do 1. It says, looking at this equation, that looks like the first one, what is the limiting value? 3. It's pretty straightforward. And they'll tell you, this is the differential equation. They'll say it's in this form, but you got to know. So what is the y value of the point of inflection? Okay, I don't think I made that clear enough. Okay, if this is the limiting capacity, half of that tells you where that growth rate is at its maximum. The growth rate is at its very maximum at this point here, and then it starts to decrease. It's always half of that, so it's 1.5. Okay, we'll do one more together. You do the next two on your own. Okay, this one, the limiting value, okay, the one where they don't give you the fraction, that first number is your limiting value. So the y point, or the y coordinate for the point of inflection would just be 8. Okay, other ways you could say that would be like, when was the growth rate the fastest? Right, what y value was the growth rate the fastest? Yeah. All right, so this will answer most of the questions on the AP exam. It'll say, what's the maximum value of the logistic function is the limiting value, or the maximum rate happens when y prime changes signs. All right, y'all do these two. Oh, this is a typo. This should say y right here on number 4. Okay, do those two on your own. Make sure you got this part, and then we'll do the next part. So the carrying capacity, that's the same thing as limiting value. Y point of the point of inflection, same thing as when the maximum rate occurs. Okay, for now, we're just going to say the maximum rate occurs at
50.
When y is 50. Be specific, it's when y is 50. We haven't talked about how to find the t number at that point, but we will. All right, so the carrying capacity for number 4 is 7. The maximum rate occurs when
3.5.
y is 3.5. Make sure you add that. The y is 3.5. This is not t. All right, next question.
Are we doing the T for TA?
We'll do it on the review. On the review, there's a review. All right, so it tells us this stuff here. It says you can derive the general solution from this. We're not going to do that. There's no point. No. They'll usually give this to you in some kind of way. Okay? So it says the rate of change, dP over dt, of the number of people entering a state park is modeled by a logistic differential equation. The capacity of the state park is 2,500. That might be important. At a certain time, the number of people in the state park is 1,200 and is increasing at a rate of 100 people per hour. Create a differential equation that could represent this situation. All right, so a differential equation, that one. Okay, there's a couple things I want y'all to notice between these two. Okay, a similarity between the two is they both have that same k number. So the k number here is the same k number down here in the general solution. What is a difference that you see? Okay, the particular solution relates t. So t is a variable in the solution. What else did y'all say? The b is just some constant you'll find.
1 plus instead of 1 minus.
There's an e in there. This one has the L. So in the difference equation, I can look at it and find the limiting capacity. Can't do that with this. But in the particular solution, if I have t values, I would use this, not this. That's what I was kind of going for. So we want to write a differential equation. So something like this. What's something we could plug in?
2,500.
Okay, I heard a couple things. What is the 100 part? That's dp dt in this case. Yeah, that's the rate. Very good. What else did y'all say?
2,500.
2,500 is what?
Carrying capacity.
The L, the carrying capacity, limiting value. So if we're looking at, don't draw this part, but like at 5 a.m. when the state park opens, no one's up, no one wants to go in. People start to trickle in as they wake up. Most people are getting there, and then it starts to level off. So the stragglers come in, and there's only so many people that go in the state park. There's that logistical curve. What's the 1,200?
The constant. Constant. That's maybe or y.
The number of people in the state park is 1,200. That's just a y number, right? Cool. We got to find what?
What's the constant?
All right, let's see what we have. So 100 is equal to k. K is all about like the specific, like some things grow faster than some logistical curves grow slower. That k constant is like the slope, you could say. Do we have the k constant? No. That must be something we'll find. What is the
1,200.
y or the p in this case would be 1,200. That goes in 2 spots. There's your L. Okay, so that's not so bad. I've got to find K. So what I'm looking for K and L. Those are the two variables that we need to plug in, the numbers that we need to find for the differential equation. So without a calculator, I could cross out those two zeros. And I could divide by 1200. Cross out those zeros. So I have 1/12 is equal to k times 1 minus 12 over 25. Yeah, multiply by 25, get 1 to be 25 over 25.
There's actually 25 minus 12, which is 13 over 25.
Nice. Multiply by the reciprocal.
So that's 25 over 13 times 12, which is 100. 156 on
So you multiply by 25. When it says 112 equals K, but this is 1 minus 12 over 25, multiply by 25.
I multiply by the reciprocal.
Oh, wait, no. So you get 25 over 25 minus.
Yeah. 25 over, yeah. Very good. That's 25 over 1. What is that?
56. Which is going to be.
Someone in first period show me this. If you multiply anything over tens, like 13 times 2, 13 times 12, you do 3 times 2. So it's 100. And then you add them, and then you multiply them.
Oh, I see.
13 times 12 would be 150 because you add those fingers and you multiply it to get 6. Isn't that cool?
Yeah, always
It works until you run out of fingers.
It's 22.
I don't know.
That's 22.
All right, we found K. That's not the answer. I'm sorry. All right, so it said create a differential equation. Okay, the differential equation is this, but with a K and an L plugged in. We have our K now. It's going to be P. Instead of Y, P, you're talking about people. 1 minus P over, what's the limiting capacity? 2,500? 2,500? There we go. We did plug in the 1,200 in order to find the K, but that could be any number of people, so we want to keep that P. Very good question. All right, let's do one more together. You'll try one on your own. We'll take a brain break. They'll show you these. Yeah. If I find one and they weren't, where they're not, then I'll say memorize them. But I haven't seen one yet. Where you need to know those. Okay, again, on the homework that I made a couple months ago, I wrote, memorize this. I don't think you need to memorize that. Just disregard that when you see the homework answers. All right, so find the carrying capacity given that. Well, that doesn't look like these. But we can make it look like that, right? So they have just like stuff in parentheses, right? So first of all, let's factor out a y and see if that helps us at all. So 1 over 150y would be the same thing as y over 150. That looks closer. But yeah, this needs to be a 1. How do you factor out 4/5? It's kind of hard. Multiply by the reciprocal, right? Okay, I'm going to take one over here. If I was factoring out, I'm just making one up. Give me a second. I'm sorry, that was aggressive. Okay, if I was factoring out a 3, what would I do? I would divide by 3, which is easy, or multiply by a third. So I would do 12 times 1/3 to give me 4. So if I'm factoring out 4/5, multiply that 1 over 150 times 5 over 4. Because we're factoring out a 4/5.
This is 5 over 600, which is
1 over 120.
120. Yeah, 1 over 120.
Yeah, 120 is the answer. I'm catching up. So divide that by 5, I get 30.
Stop, guys.
So 120. I don't do the big numbers.
Isn't it 5 over 4 y?
Victoria
Yeah,
said
you multiply by 5 over 4.
Right there, you should have been a walk. So they gave us
No, I factor out 4/5.
No, you don't. You factor out.
Don't you?
But to find out what this is, I multiply by.
Oh, you never said that.
Okay, what's 4/5 times that?
Oh, that makes sense. You're right.
So it would have got me back to this. I factored out 4/5, but to find out what this would be, I multiplied that by 5/4. So this is what I was saying a second ago. If I divided that by 3, I'm good at this. Okay, pretend it's a fraction. Instead of dividing by 3, I can multiply by 1/3. So 12 times 1/3 gives me the 4. Because we're factoring out a fraction. Yeah. That's probably easier. I like the way Abel just said it. Or a student in the back. For YouTube. Okay, instead of I'm doing 1/50th divided by 4/5. To do that, I would keep change flip, multiply by the reciprocal. So there's where that came in. It's the same thing. All right, so what's the answer? Carrying capacity, 120. Once you get it in that form, 1 fraction, carrying capacity, you should be able to look at that. All right, y'all do this one. Take a second, do it all on your own. Yeah, we're going to get there. Go back to the last one. You're on fire.
I have no clue.
This. Let's go.
Why is it not there? Yeah.
Okay, cool. What are the next step here? You have all that with the game and everything. But they're telling me this is the one. The case gets different. Yeah.
They all have. I got beans.
She's gonna say right section.
No, wait. Push it back in. No. Push it back in. Okay, so all it's going to be What he's famous, right? I saw you talking about it. It's true. I heard SAT.
It's not SAT. Like, they're not gonna have one like this one looks just like all by itself. Cause look at the earlier one.
No, I was just tired.
One of those yes two.
Yeah, I don't know whether it's
Give you a little bit more time. Y'all are starting to get there.
So is it
That's true. L is 10, I think, right? Okay. Make this look like this. Hey, the K number is not 2. The K number is not 2. Make it look like this to know what K is. For this differential equation, this would be the particular solution. I can't look at this. Okay, another form that might look like the K is 2, but not in this form. So it's got to look like this form. So make this a 1. Instead of a 10, make it a 1. How would you do that? You factor out a 10. You get 20y is equal to 1 minus y over 10. So L is 10. K is 20. Okay, they also tell you this extra little piece of information that's going to come in handy, so don't forget about it. So plug your stuff in here. Okay, this is an X, this is a Y. So 1 is equal to 10 over 1 plus B e to the negative 20 t. But t is 0. Okay, that's a t. Whoops. Thankfully, that is a 0. Anything to the 0 power is 1. So this part cancels out and it's just 1. So I've got 1 equals 10 over 1 plus b. Hopefully you can look at that and know that the b is 9. If you can't solve it, multiply both sides by 1 plus b, subtract your stuff, and you get b is 9. The answer is b.
So Caesar was right off rip.
Yeah, he was right, but just
You just didn't want
just lucky. No, he didn't deserve it. He doesn't deserve any credit. You deserve 0 credit.
If you guess every question on the AP exam correctly.
I wonder what that would be. Just guess A for everything. Don't do this. Guess A.
Sorry, guys.
Hopefully just over 25%. Get some FRQs right. There's a 3.
Let's assume you don't get any of the MCQs right. You're guessing on the whole.
Yeah, there's no point. Just don't show up. Just don't show up that day. Okay, I'm going to